So we can carry on. Okay, so the 2 came down here to the minus 2 drops the minus, comes down here. So this is PB2, and the 4 comes down here. 4. So this Roman numeral essentially came from the subscript for the anion, right? This is the cation, this is the anion, this is the subscript for the anion. So I'm going to go up here to iron oxide again. And I'm going to go to the subscript for the anion is 3. That is the charge of this iron. And it makes sense. If this was plus 3 and this is minus 2, we can look on the periodic table and tell that oxygens are minus 2. And then I crisscross, then this would become Fe2O3. You're just uncrisscrossing. It is ionic. It has a transition metal. And that transition metal is charged plus 3. And that's why is it named this way? It is ionic. It is a transition metal. Otherwise, it would just be whatever oxide. It's just the name with an IDE ending. Oh, don't forget IDE endings on everything. So whether it's covalent or ionic. Covalent, silicon dioxide. Ionic, iron oxide. Iron 3 oxide to be. And electrons are transferred. All right. First of all, what is it? It's ionic. It's a metal and a polyatomic. So we have calcium. Is it a transition metal? No. Calcium is right here. We know what is charged, so no Roman numerals in the middle. And what is a PO4 group? A PO4 group is a phosphate. PO4, phosphate. Phosphate. So the rules for ionic are add an IDE ending, Roman numeral for transition metals, and if it's a polyatomic, you just name it. It's just a name, so it's calcium phosphate. If this was nitrogen, or let's right below it, we have something that is a binary. It's just 2 elements, and that is magnesium nitride. Because it's magnesium. Magnesium is right here. We know what it's charged. It's not a transition metal. So it is magnesium nitride. So this is ionic. And that's all I need. Ionic. That's all the name. Calcium phosphate. Oh, ionic and a polyatomic. Polyatomic ion. I guess I should say that. Here, it's just an ionic compound. Ionic. So ionic compound, just the name with an IDE ending, magnesium nitride. Ionic compound with a polyatomic, it's just the name of them both, calcium phosphate. Ionic with a transition metal, it's the name with a Roman numeral in the middle and an IDE ending, iron 3 oxide. Does that make sense? I hope so. Whenever you have, God, I hope I'm spelling that right. Is it 1 R? I can't, no, I think it's 2 R's. Anyway. Transferred. Hey, I'm not an English teacher. What do you want out of me? Okay. This is ionic. Transition metal. And it's charged plus 4. That is why it's named lead 4 carbonate. It is transferred. Definitely ionic. Okay, so now we're going to go down, 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 and we have covalent stuff, and we're going from, or we have some names, and we're going from a name to a formula. So, if it's covalent, they're just telling us how many we have. So this is, the formula is silicon. Di tells me that I have 2. Monoxide means I have 1 oxygen. It is covalent. 2 silicones. They are shared because it is covalent. It is covalent. Sulfur tetroxide. Well, that seems like another covalent thing. Anytime I see Anytime I see some prefixes, I know it's covalent. So sulfur tetroxide. So I have sulfur, and I have 4 oxygens. Remember, if it's got one atom of it, one atom of sulfur, there's no mono. But if it has more than one, then we have to use a prefix. So this would be disilicone. Okay? Okay, it is covalent, 4 oxygens. They are shared electrons, and it is covalent. Okay, francium, metal or non-metal? Francium is right here. It's definitely a metal, so this is an ionic compound. So I'm going to put the formula, FRN, and then what do I have to do? How do I get these numbers? Well, I have to crisscross, right? It's not spelled out implicitly in the name, tetroxide. This is just francium nitride, so it's francium and nitrogen. The only way to know is to do the charges over them. Francium is +1, so I'm going to put a +1 here, and nitrogen is -3. So I'm going to put a -3 here, and then I'm going to crisscross. So that 3 goes to the francium, the 1 goes to the nitrogen, so that is the formula. Why is it named this way? Because it's ionic, and that's it. That's why it's named that way, francium nitride, because it's ionic, francium nitride. They are transferred, and it is ionic. Okay, ammonium sulfate. This one is problematic because while I know that NH4 is ammonium and that a sulfite is right here is SO3, -2, this is +1. There's no metals in this, is there? But what there is a cation and an anion. And so if there's a cation and an anion, then it is ionic. Now, you'll notice that everything else, sulfur and oxygen, those are both anions, sulfur and oxygen. Or silicon and oxygen, both anions, or can be anions. So really, technically, the definition of an ionic compound is a cation and an anion. I have both of these. If it's an ionic compound, I know what to do here. I have to crisscross. So this is NH4, 2, SO3, 1, because +1, -2, crisscross. It is ionic, and it is 2 polyatomics. Ions. They are transferred. I don't want to get too involved in 2 polyatomics because we're not going to deal with that a whole lot. All right, now down to here, and this is really where the fun begins. Because you have to know what this is. So 2 electrons plus 2 electrons is 4, plus 6 is 10, plus 1 is 11. Atomic number 11 is sodium. So this is sodium. And then 2 plus 2 is 4, plus 3 is 7. Atomic number 7 is nitrogen. And nitrogen. And then how do I know how many I have? I know how many I have based on charges. So sodium is charged +1. Nitrogen is charged -3. So this is Na3N. And it is sodium nitride. Because there's no transition metals. I know what sodium is charged. Sodium nitride, it is ionic. Ionic. Transferred. Ionic. Okay, next. 2, 4 plus 5 is 9, so atomic number 9 is fluorine. 2, 4 plus 4 is 8. Atomic number 8 is oxygen. Oxygen is charged -2, -1, crisscross, so I have OF2. Both of these are nonmetals. Oxygen and fluorine are nonmetals, so it is oxygen difluoride. It is covalent. with 2 fluorines. They are sharing. It is covalent. Okay, go down here. 12, let's see, 2, 4, plus 6 is 10, 11, 12, 18, 19, 20, 25. Atomic number 25 is manganese. Now, I wrote on the board that it was +1 because it's a transition metal. And just judging by this and this, you couldn't give a formula. You could just give a name. And I wanted both, so I'm going to do Mn1. And then I have 2, 4, plus 5 is 9. 9 is fluorine. So I have fluorine. And this is +1, and fluorine is -1, so MnF. And that is manganese fluoride. Manganese 1 fluoride. Remember, have to have Roman numerals if it's a transition metals. Manganese is definitely a transition metal. It's in the middle of all this, so transition metal. That is ionic. Transition metal. They are transferred. And it is ionic. Okay, so number 10. What is the ratio of the atoms? It is 1 to 2. Number 11. What is the ratio of the atoms? Oh, sorry. I did 11 first. Dang it. 10. The ratio of atoms is 3 to 1. So that is 3 to 1. And then the second one is 1 to 2. And 12 is 1 to 1. That is the ratio of the atoms. 3 to 1, 1 to 2, 1 to 1. Draw a diagram showing each of the following, an ionic bond. So I want you to remember this. You remember this? This fluorine where we had 7 electrons and it transferred 1. And so he was now negative and he was now positive, and all it would look like is this right here, right? This is ionic. That's an ionic bond. This transfer of electron, after it transfers, this becomes negative, this becomes positive. That's what it looks like. One positive atom, one negative atom. They're not connected. They're not sharing. So then covalent. Do you remember fluorine, and they share 1, and then they have these 6. And they're sharing equally, right? So this is covalent, right? That's covalent. Because there's no difference in the electronegativity. Ionic, covalent, and then polar covalent. And then polar covalent would be something like a nitrogen, dinitrogen trioxide, right? So it'd be this guy. So oxygen has a higher electronegativity than nitrogen, so he's not sharing the electrons equally. He's pulling them to him, and it looks like this. Negative, positive, and if you have that lowercase delta, that's okay too. Negative. This just means there's a partial negative charge here, a partial positive. This oxygen is pulling the electron over farther, so it's making it on the whole a little bit negative, whereas this is slightly positive. Just remember these 3 pictures: ionic, covalent, polar covalent. And that is it.